Welcome to the CMS Elementary Math 4th Grade Problem Solving Module Asynchronous course for High Dosage Tutoring. We are a team of 6 elementary math curriculum specialists. During this asynchronous course today, you will hear from myself, LaQuanda Gilmore, and my colleague, Nikki Mackey. Our goals today are to present barriers to students effectively problem solving, explore addition, subtraction, multiplication, and division problem types, introduce you to the protocol, retell, represent, and reason, build understanding of how to score the baseline, progress monitoring, and summative assessments, and to familiarize you with the structure of the problem-solving modules. There are a couple of practices that lead to barriers in mathematical thinking and effective problem solving. Overgeneralizing commonly accepted strategies, using imprecise vocabulary, and relying on tips and tricks that do not promote conceptual mathematical understanding can lead to misunderstandings later in students' math careers. We are going to start by briefly exploring several problematic practices that lead to larger misconceptions. The first problem of practice is teaching keywords. Does it always work? Let's explore.
Let's have someone read this problem aloud.
Marcia ran 73 miles in March, and Kyra ran 84 miles in March. How many more miles did Kyra run in March than Marcia?
What key words do you notice? What do you anticipate a student may do if taught the key word how many, or if taught the key word more means to add? What unintended consequences could arise from teaching keywords as a problem-solving strategy?
Keywords that I see are how many and more. I anticipate that if those keywords are taught, students may add when in this problem they are supposed to subtract. Unintended consequences that could arise from teaching keywords are students solving the problem using the wrong operation.
Let's check out another one. Here's another problem.
A basketball team scored a total of 747 points for the season. This was 9 times the number of points scored in the first game. How many points were scored during the first game?
What keywords do you notice? What do you anticipate a student might do if taught that the word times means to multiply and that how many means to add? What unintended consequences could arise from using keywords as a problem-solving strategy?
Keywords that I see here are times and how many. I anticipate that if those keywords are taught, students may multiply or add when in this problem they're supposed to divide. Unintended consequences that could arise from teaching keywords are students solving the problem using the wrong operation.
Let's try one more problem.
Laura has 3 fewer grapes than Jeremy. Laura has 4 grapes. How many grapes does Jeremy have?
What keywords do you notice this time? What do you anticipate a student might do if taught that the keyword fewer than means to subtract? What unintended consequences could arise from using keywords as a problem-solving strategy?
A key word that I see in this word problem is fewer. I anticipate that if that key word is taught, students may subtract. In this problem, students are supposed to add because Laura's amount is smaller than Jeremy's, and the question is asking how many Jeremy has. Again, unintended consequences that could arise from teaching keywords are students solving the problem using the wrong operation.
So this is called the elephant in the room that we want to talk about at the very beginning. What is the fundamental message the kids get when told to look for the key word? Don't read the problem. Don't imagine the situation. Ignore that context. Abandon your prior knowledge. You don't have to read. You don't have to think. Just grab the numbers and compute. Our goal is to support students in making sense of problem situations. As we can see in this quote, using keywords typically has the opposite outcome. Here are two snippets from the State Math Unpacking document with regards to avoiding keywords as a strategy to support solving word problems. Can I have a volunteer read the K1 snippet?
Avoid keyword strategies. Students should be asked to explain how they know why they are adding or subtracting based on the action of the word problem. Keyword strategies should not be used at any time in elementary school since they cause a dependence on specific words that do not always line up to that operation in second grade and later grades. As a result, teachers should consistently ask, what is the action in this problem and what number are we trying to find out?
How about the second grade unpacking document? What do they say about avoiding keywords?
Compare problems provide opportunities to reason about which quantity is smaller and larger, which influences whether students should add or subtract. The use of keywords to determine operations should not be used since it will lead students to do the wrong operation in second grade in future years. Alternatively, students should use part-whole diagrams, bar models, and or reasoning about the size of quantities while solving compare problems.
We have established that keywords is a strategy that will lead to later misunderstandings or development of unintended misconceptions. The unpacking documents were updated June 2022 and now have explicit language to cite why to end the use of keywords as a problem-solving strategy. This guidance also advocates for the teacher questioning to help guide students in doing the heavy lifting of the problem-solving and sense-making.
Another problem of practice that could impede mathematical thinking is called number snatching. Let's get a volunteer to read this word problem.
A cafeteria manager ordered 1,023 jugs of juice on Monday. He also ordered jugs of juice on Thursday. He ordered 798 more jugs on Monday than on Thursday. How many jugs did the manager order?
This problem has a lot of words. I'm sure many of you have seen within classrooms students getting to a story problem like this one with a lot of words and snatching out the numbers to compute them. That is what we call number snatching, just taking out or snatching the numbers they see within the word problem. What operation do you think students are most comfortable with doing once they plucked those numbers out of a word problem?
Adding them.
That's right, addition. That is what we call pluck and plus, when students just pluck the numbers right out of the word problem and plus or add them together. They may take 1,023 and 798 and add them in this scenario without reasoning about the problem first. When students are quickly asked whether they should add or subtract to solve without thorough think time about what's happening in the problem, students may feel rushed to draw conclusions about what they need to do to solve the problem.
The third problem of practice is proceduralizing problem solving. Let's look at this anchor chart you might see hanging in a lot of teachers' rooms. What do you notice? Do you see anything familiar there? Is this promoting problem solving or memorizing a procedure? There are other procedural acronyms, maybe from Teacher Pay Teachers, that teachers may utilize as a quick fix for helping students think through problems. Cubes is a well-known example of this. But beware of any procedures where students are asked to memorize steps that limit their opportunities to think critically through a problem for themselves. When teachers suggest an attack strategy, they are attempting to support students with making sense of word problems. But not all attack strategies are created equal. These are two popular ones. And students have good intent with trying to help students solve problems. So, if this isn't helpful, what should we do? Research tells us there are two supports that can be provided for students who are struggling with word problems. The first thing is an attack strategy. This tutoring intervention that we are sharing with you today is based on a different attack strategy. It's focused on steps students can do to make meaning of a problem. This research tells us this is what they need. So we will use schema-based instruction, also known as graphic organizers, for different problem types, along with our protocol retell, represent, reason. We'll learn more about that soon.
Another problem of practice is teaching math tricks. Math is not magic. It represents real-life situations involving quantities. We also want to prevent teaching tricks because these tricks sometimes expire and are not always applicable in subsequent grades. Here are a few tricks that we've heard before. Keep, change, flip. Have you ever heard this? I wonder in what grade and for what mathematical concept you may have heard keep, change, flip.
Oh, I've heard this in 5th grade classrooms when students are learning how to divide fractions.
Oh yeah, we keep the first fraction, change the division sign to a multiplication sign, and flip the second fraction to compute. While doing this trick, students will get the right answer, but we have to ask ourselves, is that all that we want for students is to get the right answer? Teaching this trick takes all of the higher order thinking away from students and does not promote reasoning. We want for students to be able to make sense of what they are doing. Let's read another trick.
If the numbers are 10 or less, you multiply. If they are larger than 12, just divide.
What grade level have you heard this trick being used in? How do you think that confuses students?
I think I heard that in 3rd because they only work within numbers of 10, and if they're working with those single digit numbers and they need to come up with a total, they're going to learn just to multiply. But that's not always true. That the numbers get bigger later on.
That's right, because students in 3rd grade only learn multiplication facts up to 10. So if the numbers are larger than 10, and I taught my students this trick, they would know to divide. When will this trick not be helpful anymore? Can you see how this could be confusing for students? We've also heard things like, when writing an equation, always start with the largest number, or in a fraction, the larger number always goes on the bottom. And we know that those statements are not always true. Overgeneralizing a concept, removing the context of the problem, or teaching tricks about numbers prevents students from being able to effectively solve problems. Is it working? What knowledge do we need as instructors to extinguish the ineffective practices we just unpacked? In CMS, we have been working on growing teachers' knowledge about grade level problem types in conjunction with a problem-solving protocol. In the learning module, we will orient ourselves around what North Carolina defines as the addition and subtraction problem types, as well as guidance around problem-solving in K2, and the multiplication and division problem types learned in grades 3 and 4.
The problem-solving modules are tools to assist students who need additional practice with problem-solving techniques. Students who struggle with word problems. so that's why they were developed. Our department received numerous questionings regarding intervention programs for students that have computational fluency but struggle with problem solving. And when Susan reviewed the data, standards involving problem solving confirmed that there was a concern. After countless hours of research trying to find a program that we could adopt, we recognized that there were none. So Susan connected with Dr. Drew Pauly at UNC Charlotte to identify a research-based intervention that could be used if we built our own modules. The only thing I had seen really effective before supporting students with problem solving when I worked as a facilitator in a school is a protocol called Retell, Represent, Reason, originally developed by a fellow math facilitator, Laura Handler, at another CMS school. Dr. Pauly and Susan developed some clarifying questions that aligned with the research-based practices to guide teachers as they implement the protocol. Then we gathered a team of CMS teachers and facilitators to create the modules. We implemented a small pilot study. We collected some promising data, but we also learned some new information from our pilot study and current research in the field. Based on what we learned, the research team, including UNCC and CMS, made some enhancements to improve student outcomes. The math problem-solving curriculum was identified to support a tutoring initiative. In recent years, we worked with UNCC to conduct a research study using the curriculum with 4th grade students. This curriculum was developed by CMS in response to having no math problem-solving interventions in the market to address MTSS needs in this area. Problem solving. Based on the UNCC research study, the mean score for the treatment group was higher on the post-test than on the pre-test, while the mean score for the control group did not change significantly. The difference in growth between the groups was found to be statistically significant, meaning that we can be confident that the results are not due to chance. This suggests that problem-solving intervention was more effective than the business-as-usual intervention for developing 4th grade students' word problem-solving skills. For the second semester of the school year, we would like to focus on 4th grade math as one of the district's tutoring efforts. Based on EVOS data, there is room for improvement when comparing EVOS data from 2 current school years. We did meet growth, but we want to work on exceeding growth.
For the next part of this training, you will need access to a few resources. To access the resources, please visit the bit.ly listed on the screen.
The first link on the one-pager is a note catcher. Feel free to take notes as we discuss the addition and subtraction word problems. In your note catcher, you'll notice 2 questions. How does the context impact the problem type? How does moving the unknown impact how a problem is solved? Let's talk about these addition and subtraction problem types. NCDPI includes 4 types of addition and subtraction problems in the North Carolina Standard Course of Study, which was revised in 2022. The types are add to, take from, put together, take apart, and comparison. Each of these problem types can have unknowns in different places. We will look at each of these problem types on the next few slides. Consider how the context defines the problem and how the unknown impacts the strategy for solving. You can have your own copy of the problem types by clicking the second link on the one-pager. The first problem type are add to problems. We call these video problems because you can see the action happening. In add to problems, you begin with some, you get some, and now you have a new amount. So for example, I have 4 cookies, Mom gave me 2 more cookies, now I have 6 cookies. Any piece of information can be unknown for a math problem. The result can be unknown. We practiced these in kindergarten. I have 4 cookies, Mom gave me 2 more. How many cookies do I have now? The change could be unknown. These are practiced in 1st grade. I have 4 cookies. Mom gave me some more cookies. Now I have 6 cookies. How many cookies did Mom give me? The start could be unknown. This is practiced and introduced in 2nd grade. I had some cookies. Mom gave me 2 more cookies. Now I have 6 cookies. How many cookies did I have to begin with? Take a minute and jot down any notes in your note catcher about add to problem types. The second type of problems are take from problems. These are also video problems because you could record the action happening. In take from problems, you begin with some are removed, and now you have a new amount. So for example, I had 6 cookies. My sister ate 2 of my cookies. Now I have 4 cookies. Any piece of the information can be unknown for this math problem. It could be result unknown. I had 6 cookies. My sister ate 2 of my cookies. How many cookies do I have now? Introduced in kindergarten. The change could be unknown. I had 6 cookies. My sister ate some of my cookies. Now I have 4 cookies. How many cookies did my sister eat? This is first grade. And in second grade, we practice and introduce start unknown. I had some cookies. My sister ate 2 of my cookies. Now I have 4 cookies. How many cookies did I have to begin with? Take a minute and jot down any notes in your note catcher. The third set of addition-subtraction problem types are put together, take apart problems. We like to refer to these as photo problems because there is no action. You can see the whole situation at once and take a picture, but you cannot record the action. That sometimes makes this type of problem a little harder for students. In these situations, there are 2 parts and a total of the 2 parts. In this example, we have 3 red tiles and 4 blue tiles. Altogether, I have 7 tiles. Notice that the red nor blue came first. There is no action of the group being added. Again, any part of this situation can be unknown. The total can be unknown. I have 3 red tiles. I have 4 blue tiles. How many tiles do I have? The smaller part could be unknown. I have red and blue tiles. I have 4 blue tiles. I have 7 tiles altogether. How many red tiles do I have? The larger part can be unknown. I have red and blue tiles. I have 3 red tiles. I have 7 tiles altogether. How many blue tiles do I have? This problem type has another possible unknown called both unknown. In this case, the total is presented and students have to come up with possible combinations. Students are typically expected to come up with at least 3 possible answers if both are unknown. A both unknown problem type might sound like this. I have 7 tiles. Some are red and some are blue. How many red and blue tiles might I have? Show 3 possible answers. Take a minute and pause here and jot down any notes in your note catcher about put together, take apart problems. The final set of addition-subtraction problem types are comparison problems. Like put together, take apart problems, we refer to these as photo problems because there is no action. You can see the whole situation at once and take a picture, but you cannot record any action. This tends to be the most difficult problem for students. In these situations, there are 2 quantities being compared. In this example, we see 8 red tiles and 3 blue tiles, and the difference between the 2 colors of tiles is 5 tiles. Again, any part of this situation can be unknown. With this problem type, the questions can be adjusted using comparison words like more and fewer. The difference can be unknown. We practiced this in first grade. I have 8 red tiles. I have 3 blue tiles. How many more red tiles do I have? Or I can ask, how many fewer blue tiles do I have? Both the more and fewer questions should be used for difference unknown problems. The smaller part could be unknown. I have red and blue tiles. I have 8 red tiles. I have 5 fewer blue tiles than red tiles. How many blue tiles do I have? Or, I have red and blue tiles. I have 8 red tiles. I have 5 more red tiles than blue tiles. How many blue tiles do I have? The larger part can be unknown. I have red and blue tiles. I have 3 blue tiles. I have 5 more red tiles than blue tiles. How many red tiles do I have? I have red and blue tiles. I have 3 blue tiles. I have 5 fewer blue tiles than red tiles. How many tiles do I have? Take a minute and jot down any notes about comparison problems. If you're meeting with a group or training with a group, turn and talk about what your key takeaways are regarding the addition and subtraction problem types.
We will now look at multiplication and division problem types. On your one-pager, you may access the note catcher for multiplication and division. The first multiplication and division problem type involve equal groups. There is a number of groups. Each group has the same number of things, and there is a total number. An example would be, I have 8 bags. Each bag has 3 blue tiles. There are 24 blue tiles. As with the addition and subtraction problem types, the unknown information can be any one of those. For example, the total can be unknown. I have 8 bags. Each bag has 3 blue tiles. How many blue tiles do I have? The group size can be unknown. I have 8 bags. Each bag has the same number of blue tiles. I have 24 blue tiles. How many tiles are in each bag? Or the number of groups can be unknown. I have some bags. Each bag has 3 blue tiles. I have a total of 24 blue tiles. How many bags do I have? Note that this example is with discrete objects. That is, objects that are seen as separate pieces. But similar situations can be created with measurement units such as miles, liters, hours, and pounds. Here is a measurement example. I have 8 bottles of soda. Each bottle has 2 liters of soda. How many liters of soda do I have? Let's talk about the difference between a situation equation and a strategy equation. The situation equation matches the situation taking place in the word problem. The strategy equation is an equation that may be used to solve the situation that is taking place. If a student is struggling to make sense of an equation, you would want to encourage them to write an equation based on the words in the story. Some students might just jump to a strategy equation to solve. They may not need to write a situation equation first. Here, you can tell the difference between the situation equation and the strategy equation. The situation equation matches the situation of 8 bags, and each bag having the same number of blue tiles, which is unknown, and there are 24 blue tiles. The strategy equation, representing division, begins with the total of 24 blue tiles and is dividing the number of bags to find the group size, or the number of blue tiles in each bag. Pause the video now to jot down any key takeaways. The second type of multiplication and division problem involves arrays and area. For arrays, there is a number of equal rows, a number of equal columns, or an equal number of items in each row. And there is a total number of items. For area, there is length, width, and area. The example here is there were 4 rows of chairs. Each row had 7 chairs. There were 28 chairs. As with the addition and subtraction problem type, any part can be unknown. The total can be unknown. There were 4 rows of chairs. Each row had 7 chairs. How many chairs were there altogether? The number in each row may be unknown. There were 4 rows of chairs. Each row had the same number of chairs. There were 28 chairs altogether. Or the number of rows may be unknown. Chairs were placed in equal rows. Each row had 7 chairs. There were 28 chairs in all. How many rows were there? Area problems also fit into this problem type. The area may be unknown, the length may be unknown, or the width may be unknown. Pause the video now to jot down any key takeaways. The final multiplication problem type involves multiplicative comparison. This problem type is introduced in 4th grade. As with additive comparison, a smaller and larger quantity are being compared. However, with multiplicative comparison, the 2 quantities are compared by considering the multiplicative relationship of how many times bigger the larger quantity is than the smaller quantity. Here is an example. There were 4 books on the first shelf. The second shelf had 6 times as many books. There were 24 books on the second shelf. Just like with other problem types, any of these parts can be unknown. The larger quantity, unknown. There were 4 books on the first shelf. The second shelf had 6 times as many books. How many books were on the second shelf? The smaller quantity may be unknown. There were 24 books on the second shelf of a bookcase. The second shelf has 6 times as many books as the first shelf. How many books are on the first shelf? Or the multiplicative relationship can be unknown. The first shelf has 4 books. The second shelf has 24 books. How many times more books does the second shelf have than the first shelf? This problem type can occur with discrete objects or measurement units. An example with measurement units is there were 2 cups of water in my glass. A jug has 16 cups of water. How many times more cups of water are in the jug than in the glass? Pause the video now to jot down any key takeaways about comparison problem types. Take a moment to finalize your thoughts about multiplication and division problem types. If you are working with a partner, you may also share some key takeaways regarding context impact and the location of the unknown. You will now engage in a problem type sort. In this sort, there are 12 word problems alongside the graphic organizer. Your job is to read the word problems and determine which addition and subtraction problem type it aligns to, and determine where the unknown is located in order to correctly place it in the chart. You may want to think about if there is an action taking place in the word problem, or if it is a picture image. As an instructor, having knowledge of the different problem types can dictate what kinds of questions you ask to help students problem solve. You may use the problem type handout to help you with sorting. Pause the video here to complete the problem type sort. Take a moment to check your work.
Next, we're going to move into the protocol. In your one-pager, you can find the checklist for Retail Represent Reason. This is what the protocol looks like. You won't have to ask all of these questions, but they are here to reference to prompt students and move through the protocol. Let's get into it. During the retell part of this tutoring intervention, pencils are down and students are being challenged to make sense of the mathematical situation. For each problem, teachers will ask the student to retell what is happening in their own words, and that is without rereading. We ask students to turn their papers over so they have to retell without rereading the problem. Then the teacher asks about the quantities using the questions such as, what does the 28 mean in the problem? What does the 17 mean in the problem? And then the teacher asks, so what is it that we're trying to find out? Notice that all of these questions are designed to support students in the process of making sense of a problem. It is important that teachers ask students these questions rather than telling them, so that students learn to make sense of the situation on their own. So remember, when we ask students to retell, we want to hear the gist of the story first. They don't have to talk about the numbers. Once they retell and have the gist, then we can ask them what the numbers represent. Pause here and practice retelling with a partner when it comes to this story. The next part of this protocol is represent. Students should have access to paper and pencil and objects and math tools. Students should ask, how can you represent this problem? If the student doesn't respond, then the teacher can probe further. How could you use pictures or blocks to represent this problem? If a student is still stuck, the teacher could read the first phrase of the problem and ask the students how to represent that part. For example, a teacher might say, the problem says Camilla has 28 stickers. How could you represent this part of the problem? Ask students to write an equation to represent the situation if the student does not write an equation. Since understanding symbols is cultural, the meaning of symbols must be taught if students don't understand the meaning. For example, the addition sign means something and is being added or things are being put together. Subtraction sign means that we are taking away or finding the difference, or how far apart two numbers are. The multiplication symbol means we are combining the same size groups, and division symbol means we are separating into equal groups or taking away equal groups. At first, writing an equation may take more guidance, but students should be encouraged to do this as independently as possible. Let's look at different types of representations. Students need to have ample time to manipulate tools to match the context they are given. Then students move towards drawings or diagrams to represent the context. Once students have had those experiences, using numbers and symbols makes sense to students to represent situations. I do want to emphasize that one doesn't delete another. Students may use pictures to represent the situations and then write an equation. These are all acceptable ways to represent a problem. Students might use graphic organizers to represent a problem. Students might use a graphic organizer like this one for the compare problem we just read. It says Camilla has more stickers, so we know here is the larger. We also know that Camilla had 28 stickers, so we can place 28 in the larger space. We also know that the difference is 17 more, so we could put 17 in the difference space. We are trying to find the smaller amount. Notice that the key word might have tricked us into adding, but the graphic organizer helps us to see that Jada is the smaller, so we subtract. When a new problem type is introduced in the modules, the teacher shows a graphic organizer and creates an anchor chart to display for students to reference. Pause the video here and look over the graphic organizers in your one-pager.
The final step of the protocol is to reason. This is the part of the protocol that is most often overlooked, primarily because in the previous section of the protocol, students found their answer. So in their heads, they are done. However, we always want to reason and make sense of the work we just completed. An analogy we like to use here is that reasoning is like flossing. It is part of the process that we know is important, most times forget to do it. In the last part of the protocol, students are challenged to make sure their answer is reasonable. They already identified the answer in the represent part of the problem, but good mathematicians have a habit of making sure their answer is reasonable. Students consider the context and their answer to make sure it makes sense. Students who justify they are correct by using the opposite operation are not actually reasoning about why their answer makes sense based on the context of the problem. They are proving their computation is correct, but we need students to go further in their reasoning. What would we want to hear students say as they reason about their solution to this problem?
Jada's number of stickers had to be less than Camilla's, so my number makes sense.
Pause the video now to jot down any important or key takeaways in the blank section of your note catcher titled Reason. If you have a partner, let's practice using the Retell Represent Reason protocol. Talk together about what type of problem is posed and how you know. As the teacher, try to leverage this knowledge to align your retell questions to support your partner in understanding what the quantities represent, what they are trying to find out, and what action to take. Remember to stay away from keywords, proceduralizing the problem type, etc. And really support critical thinking in your own practice. If you do not have a partner, think through the problems that are projected and what questions you may ask students based on what you've learned about problem types in the Retell Represent Reason protocol. Pause the video here to practice using the Retell Represent Reason protocol.
Let's think about assessing student progress. The modules you will be using contain a baseline assessment, 4 progress monitoring assessments, and a post-assessment. You will give the baseline at the beginning to make sure the module is appropriate for the selected students, and you will give the post-assessment at the end of the module. The post-assessment is a parallel assessment to the baseline. That means the same type of questions will be assessed at the beginning and the end. Each assessment, including the baseline and the post-assessment, have 4 questions. Students will be expected to have a representation and an equation and identify the answer. You will score the assessments using this rubric. Students may receive 2 points for a picture drawing, 2 points for a matching equation, and 2 points for the correct answer. Note that the equation may match the situation, or it could be a strategy equation. On your one-pager, you will see an image that has this scoring rubric on it. Let's practice some scoring. On your one-pager, you will see an image that has this scoring rubric on it. Let's practice some scoring. Click on the fraction student work in your one-pager and take a minute or two and look at the 3 work samples you have there. Think to yourself, does the student representation accurately show the context of the word problem? Can you determine the problem type based on the student representation? If you were grading this student work, would you give this student credit for their representation? Why or why not? Look at all 3 works and we will come back and talk about them. Let's look at Ramaya's work. We notice that there are 2 wholes being partitioned into 6 parts. 1 whole and 1/6 is shaded, and 2/6 is circled and labeled Marco. The rest of the 1 and 1/6 left is 5/6 and it's labeled Mia. The representation is clear and it mirrors the information in the story. I would give 2 points for this representation. Let's look at the equation here. The equation is a strategy equation that combines the 2 parts to make the 1 and 1/6. the student could receive 2 points. When the student identifies the answer, this student did not state the unknown. Remember, the question was, what fraction of the bag of candy did Mia have in the beginning? No points would be awarded for the answer. Let's look at Lila's work. This representation tells me that I know Lila can partition wholes into 6. I think I would need to ask her to explain her thinking. And that's okay, you can do that. You can ask students to explain what they were thinking. I believe that I see 2 6 in one of the holes, and I believe 2 of the rectangles are showing me 1 and 1 6. But I'm not sure what's happening with them. Based on this picture representation, I would give her 1 point. The equation has a part and the whole being combined. Since that's not what's being asked in the problem, she would receive 0 points. Since the student didn't solve for what the fraction of the bag of candy that Mia had in the beginning, the unknown or the answer is not correct. So it would not be reasonable for Mia to have that part of the bag and that part to be larger than 1 and 1 6. So 0 points for the answer. Let's look at the last fraction, student work. So this representation uses the tool, the number line, and the student started at 1 and 1 6 and jumped back to 5 6 on this number line. The 2 6 that's decomposed into 1 6 and 1 6 is labeled Marco, so we see his bag of candy. The student did make 1 too many tick marks on this number line, but I don't think this enabled the student to use this tool to find the answer. I would just watch to see if this student creates number lines in the future. Does he continue to make too many tick marks, or was that just a quick mistake in this one? So this representation is pretty good and it matches this situation, so I would give 2 points. The equation is a strategy equation, but it works. So they were taking 1 and 1 6 and subtracting 2 6 to find 5 6. So 2 points for the equation. And the correct unknown is identified in the answer. So 2 points for the answer. Let's look at some more student work.
You will score the next set of student work using the same scoring rubric. Students may receive 2 points for a picture or drawing, 2 points for a matching equation, and 2 points for the correct answer. Remember that the equation may match the situation taking place in the word problem, or it may be a strategy equation. Take a look at the multiplication and division student work samples. Using the scoring rubric, decide how many points you would award each student's work for their picture, equation, and answer. Pause the video to score the student work samples and return to the video after you have completed. Let's take a look at Carlos's work. Samuel has packs of football cards. Each pack has 12 cards. He has 36 cards altogether. How many packs of cards does Samuel have? Looking at Carlos's work, I would give him 1 point for his pictorial representation because it does not represent the context of the word problem accurately. Though I can see he does have some knowledge of multiplication, the word problem says that there should be 12 cards in each pack, and Carlos has 3 cards in 12 packs. Carlos's equation, 36 divided by 12 equals 3, would be awarded 2 points, and his answer of 3 would also be awarded 2 points. In thinking about Dylan's work, looking at his pictorial representation, I can see that he has a bar diagram with a whole of 36, and that 36 being broken up into 3 equal pieces. each with 12 inside of them. So that pictorial representation would receive a score of 2 because it accurately depicts the context of the word problem. His equation of 3 or blank or unknown times 12 equals 36 would also receive a score of 2. And his answer of 3 groups of 12 would also receive a score of 2. Looking at Anaya's work, I would award her 0 points for her answer because she is not sure about where her answer lives at in her pictorial representation or in her equation. This is why labeling parts of pictures and equations is beneficial so that students can make sure they are answering the question being asked. In her pictorial representation, Anaya does have 3 packs of cards, each with 12 cards inside. Looking at Anaya's equation, 12 plus 12 equals 24. That 24 added with another group of 12 equals 36 would be awarded 2 points because it accurately shows her 3 groups of 12 being added together to get 36. Her answer of 36 does not answer the question, how many packs of cards does Samuel have? So that would be awarded 0 points. Looking at Anaya's equation, seeing how she likes to use repeated addition, when I pull her next week, I would work on making connections between her strategy of using repeated addition with a more efficient strategy of multiplication and showing her how repeated addition is the same thing as multiplication so that she could use that in her later work. We are going to spend a little time getting familiar with the resources that we will be using for the high dosage tutoring program. The curriculum is called Retell, Represent, and Reason Problem Solving Curriculum. And as you have seen, it is evidence-based according to the recent research study conducted by UNC Charlotte. This curriculum should be implemented 15 to 20 minutes for 3 times each week for 10 weeks. There are progress monitoring probes to determine the impact of the instruction or tutoring taking place. These sessions should occur during morning work time, intervention time, center time, or after school. Please note that specific 4th grade students should be selected to access this curriculum. This means that 4th grade students performing below the 21st through 40th percentile on iReady should be selected to participate. The reason for this is that students below the 20th percentile receive interventions and leaving the students within the 21st through 40th percentile with minimum support. And when we pull the data set for the group of students in the 21st through 40th percentile, they are more likely to not perform on grade level according to the end of grade assessments if additional support is not provided. Let's take a look at the timeline for this tutoring program. You will use iReady data to determine potential candidates. Remember, anyone falling within the 21st through 40th percentile will then be baselined for Rational Numbers Module C as soon as possible. After students are baselined and they score less than 18 on the Rational Numbers Module C, they will begin tutoring. Tutoring will take place 3 times a week with progress monitoring happening every 2 weeks. School champions should check in with specialists monthly, and school champions should check in with tutors weekly. Analyze the data, the baseline data, the progress monitoring data, and the summative data for next steps.
Next, we're going to review the framework for problem-solving modules and give you a chance to put your notebook together and familiarize yourself with the resources. You can find the framework in your one-pager, click the link, and pause the video here to read over those points. Some of the materials you will receive is a large white binder that will include the materials for rational numbers modules C and D, and clipped separately will be multiplication and division module E. We will start with rational numbers module C, and we cannot offer multiplication and division module E until Unit 5 and Unit 6 has been taught in the core instruction. Let's talk about what's inside your binder. When you open up, you'll see a blue piece of paper, and right behind that blue piece of paper is our Module C Supplemental Intervention. You'll see the problem types, outline of the sessions, suggestions for teaching the modules, and right behind that is our protocol. And then you will see an orange piece of paper to start Module C. And the baseline is on the first 4 pages. And then you will see week 1, day 1, problem 1. Problem 2 for day 1. Day 3, problem 1. Day 2, problem 1. Day 2, problem 2, and so on. And one student's materials are up until you get to the next orange piece of paper, and you'll see another set of materials for Module C. There are 3 sets of materials for each module because you'll be working with groups of 3. If you are working with more students, we will provide you with page protectors and dry erase markers so that you can put their weekly meeting time, the problems they're going to work with when they're with you, and page protectors so that they can be reused again for another group of students. Your champion has digital copies if you need to make more copies. Also in this binder is a blue piece of paper separating Module C and Module D. And again, you have enough materials for 3 students. All your progress monitoring and summative assessments will be included here. And then this is what the clipped module looks like, the multiplication and division that we are not going to do until after Units 5 and 6 are taught, but same setup here. And a reminder, you will receive 3 dry erase markers and some grid paper and also page protectors. Let's talk a little bit about the module baseline. There are 4 problems. It's not timed. Each problem is worth 6 points, just like we practice. The rubric includes the points for the representation, the equation, and the answer. You may read aloud the problems as needed. We know that students are able to have read aloud, so let's not make that be a barrier for them. You will administer the rational numbers Module C baseline. If a student scores between 0 and 17 points, Module C is appropriate for that student. If a student scores 18 points or higher, administer rational numbers Module D baseline and follow those same rules. If they score below 18 points, then Module D is appropriate for that student. If a student scores 18 points or higher, we will discuss the supports for those students in our champion check-ins. Students are not ready for the multiplication and division module just yet because they are working on that in their core. Units 5 and Unit 6 need to be completely taught before we can give them that Module E. You will notice that module will be clipped together with a binder clip. It will not be included in the binder. All schools have folders where the data is kept, and you will receive access after completing all parts of the training, but it looks like this, where each student has a tab across the bottom, and we will keep track of their data as they move through the protocol and they move through all the modules. School champions are encouraged to meet with tutors weekly to review upcoming problems and to review data from each progress monitoring.
We want you to have the same experience fourth grade students will have beginning this module so that you are able to relate and provide support. After you complete the initial assessment or baseline, please scan it and send it to the email address listed on the screen. On your one-pager, you may also access this baseline assessment. Once baselines and reflections are received, access to materials will be available to begin tutoring. Pause the video now to complete the baseline assessment independently. Use the link for asynchronous training reflection located in the High Dosage Tutoring Resource one-pager. Please complete the Google form documenting 3 things that you have learned after completing today's training, 2 things that you feel you need in order to be successful with implementation after this training, and 1 immediate next step you will complete after the completion of this training. Pause the video now to complete the reflection form.
Thank you for spending some time with us today. We appreciate your time to tutor our 4th grade students. Be sure to submit the baseline assessment and complete the reflection form in order to access the materials. We will be in touch. Take care.